Well, g'day Year 7s. I hope this whole working from home thing is working out okay for you. I can say from my end, from what I'm seeing in terms of emails and things, it seems like you're all doing a great job. So I'm really happy that you've all gotten a good start. All right, so I thought we'd kick off the week with a little video, our first video actually. I'm going to be making quite a few videos and uploading them to this YouTube channel. All right, so we're going to start the week just by recapping a bunch of the fraction skills that we've learnt so far, okay? So we're just going to go through one example per skill, all right? All right, starting with number 1, converting improper fractions to mixed numbers. Remember, an improper fraction is a fraction where the numerator is bigger than the denominator. Okay, so 21 over 4. 21 over 4. Let's convert that into a mixed number, which means a whole number followed by a proper fraction. All right, well, that's simple. How many 4s go into 21? Well, we have 5 4s going into 20 exactly, with a remainder of 1, okay? So the answer must be 5 wholes and 1/4 remaining. Easy. If the question had been, 22 quarters, well, 4 goes into 22 exactly 5 times with a remainder of 2. So 5 2/4, which is 5 1/2. Okay. All right, moving along. Converting mixed numbers to improper fractions, so going back into the other direction. This is very straightforward if you remember the following. All right, we have 5 2/5. So here's what we do. We take this number and we multiply it by this number, giving us 25, and then we add to 25 this number. So we do a little loop-de-loop. 5 times 5 is 25. 25 plus 2 is 27. Okay, so let me get rid of that mess. We have 27. Well, 27 over what? 27 over 5. The denominator stays the same. Okay, so just to recap, 5 times 5 is 25. 25 plus 2 is 27, and the denominator stays the same. Okay, moving on. Skill number 3, creating equivalent fractions. That just means fractions that are equal to each other. So create any fraction that is equivalent to 4/7. All right? So you might think that's a very open-ended question. Which equivalent fraction, you might ask? Well, it just says any, and there are infinitely many options. All you have to do is multiply the numerator and the denominator by the same number, any number, just pick a number. All right, let's just do something simple. 2. 2 over 2. Why can I multiply 4/7 by 2 over 2 and get a fraction that is equivalent to 4/7? Well, think about it. 2 over 2 is 1. 2 over 2 equals 1. And you can multiply any number by 1 without changing that number, okay? All right, so to multiply fractions, we simply multiply the numerators. 4 times 2 is 8. And we multiply the denominators. 7 times 2 is 14. There we go. We've created an equivalent fraction. And like I said, there are infinitely many ways that you can do that. All right, simplifying fractions. Okay, so there's a couple of ways to think about this. We're going to consider both options. All right, 12 over 15. We need to simplify that down. I'm going to do it in 2 different ways. So 12 over 15 equals, all right. One way is to ask yourself, what is the highest common factor of 12 and 15? In other words, what is the highest number that divides into 12 and 15, into both those numbers, without a remainder? Well, they actually only have, these two numbers only have one common factor except for one, which is 3. So I'm going to divide both numbers by 3. 12 divided by 3 over 15 divided by 3. And what do I get? Well, 12 divided by 3 is 4. And 15 divided by 3 is 5. 4/5. Can't be simplified any further. All right, well, that's all good and well for small numerators and denominators, but if you're trying to find the highest common factor of two numbers that are much bigger, it can be very difficult. So quite often it's helpful to bust the numbers down into some of their factors. And this is what I mean by that. So 12 over 15, well, one way that we can rewrite 12 is 3 times 4. 2 times 6 also. All right. Another way that we can rewrite 15 is 3 times 5. And if you look at that fraction, there's a 3 on the top, in the denominator, I should say. I should use the correct terminology, and a 3 in the numerator, okay? And I just said those back to front, and I can't be bothered editing this video. There's a 3 in the numerator, nearly did it again, and a 3 in the denominator. All right, why can I cancel those out? Well, what does it actually mean to cancel out? By crossing out those two 3's, I'm doing 3 divided by 3, which equals 1 over 1, or 1, okay? And 1 times 4 is 4. 1 times 5 is 5. So the answer is 4 over 5, 4/5. Okay, so there's a couple of ways of thinking about simplifying fractions. All right, moving on. Skill number 5, evaluate and simplify the following. So we're looking at multiplying fractions now, even though we just did a little bit of that already, okay? So evaluate and simplify. So I can simply multiply the numerators and multiply the denominators and get a new fraction and then simplify from there, or I can be a bit cleverer about things and do the following. We have 5/6 times, why isn't my pen working? Times 36 over 10, okay? And at this stage, what I can do is start rewriting some of these numbers as products of 2 or more other numbers, and then find things to cancel out. So 36, if I sort of think ahead a little bit and look down here, I can see that there's a 6 on the bottom of this fraction. So wouldn't it be convenient if I could factor the 36 into something times 6 and cancel out a couple of 6's? Well, 36 is actually 6 times 6. So I'm going to replace the 36 with 6 times 6 over, well, 10. But I'm not going to write 10 because, look, up here I have a 5. So wouldn't it be convenient if I could replace the 10 with something by 5? It's not always possible, but this is what we look out for. In this case, it is possible. 10 equals 2 times 5. Okay? All right, so now I can do some cancelling. 6 divided by 6 is 1, so they disappear. 5 divided by 5 is 1, so they disappear. So what do I have left? I have a 6 and a 2 left. All right, so this equals 6. Oh my goodness, my pen is driving me bonkers. 6 over 2, which can be simplified even further. 6 divided by 2, well, that's 3, isn't it? Easy. All right, moving on. We're almost there. Dividing fractions. Well, dividing, if you know how to multiply fractions, then you know how to divide fractions as well. It's just a simple process of changing division into multiplication, okay? So here's what we do. Evaluate and simplify the following. All right, so we have 9 over 7 divided by 12 over 28. Now the rule when it comes to dividing one fraction by another is that you rewrite the first fraction, you change the division symbol to a times sign, and you flip the second fraction upside down. So the numerator and the denominator switch places. And now if you know how to multiply fractions like we did in the last problem, then you're good to go. Okay. So let's see. 9 I'm going to rewrite as 3 times 3. I think that might help me. 7's a prime number, so there's not much I can do about that. 28 though, that's 4 times 7, isn't it? So I'm going to be able to cancel some 7's. And 12, well, I can write that as 3 times 4, which is convenient also, because now I can go cancel, cancel, look at this, cancel. Okay, all that's remaining is this 3 here. So the answer is 3. Didn't expect that to work out quite so tidily. Lovely. All right, moving on. Just a couple more. All right, adding and subtracting fractions. Okay, this is what people find a little bit tricky, because what a lot of people think is that you simply add or subtract the numerators and add or subtract the denominators. That is not the case. It doesn't work the same way as multiplication. We need to change our fractions so that they share the same denominator, okay? So, let's think about this. We have 7 over 4 minus 5 over 6. Okay, now what is the lowest common multiple of 4 and 6? So if I wrote out a list of the first, 10 multiples of 4 and the first several multiples of 6, what would be the lowest number that appeared on both of those lists? You might think it would be 24, because 4 and 6 both go into 24. And quite often the lowest common multiple is actually just the two denominators multiplied together. But if you look carefully, you'll see that that's not the case for this example. 4 and 6 both go into 12, don't they? Okay, so the lowest common multiple is 12. So now you have to ask the question, how do I turn the first denominator into a 12? How do I turn 4 into a 12? Well, I multiply it by 3. So here's what I do. I take the fraction 7 over 4 and I multiply it by, not 3, I multiply it by 3 over 3. Remember, we can only work with equivalent fractions. I can't just change 7 over 4 into something entirely different. I can only multiply it by something that's equal to 1. All right, so 7 over 4 times 3 over 3. That's going to give me a denominator of 12. Minus 5 over 6. Well, how do I turn a 6 into a 12? Well, I multiply it by 2. So I'm going to multiply that fraction by 2 over 2. Because that equals 1, which means I'm not breaking any of the rules of maths, okay? Running out of space, but doesn't matter. All right. So now we can do two separate multiplications. 7 times 3 is 21 over 4 times 3, which is 12, minus 5 times 2, which is 10, over 6 times 2, which is 12, okay? All right, now it's easy because the denominator is the same. 21 over 12 minus 10 over 12. So 21 twelfths minus 10 twelfths. It's like saying 21 pizzas minus 10 pizzas. It's easy. If you know how to do 21 minus 10, that is, which you do. 21 minus 10 is 11. So the answer is 11 twelfths. Okay. All right. One more question. Reciprocals. You might have forgotten what that word means. The reciprocal of a number is 1 divided by that number, 1 over that number, okay? So let's actually do B first. So the reciprocal of 7, okay, reciprocal of 7 is 1 divided by 7. Easy. All right, well, what's the reciprocal of 2 over 13? Well, let's have a look. Reciprocal of 2 over 13 equals, well, it equals 1 over 2 over 13. But that would look a bit weird if I did a fraction over a fraction. So I'm going to use a division sign because it has the same meaning. 1 over, or divided by, 2 over 13. Okay? But we learnt a rule, didn't we? We can turn division problems with fractions into multiplication problems. So long as you have if you have one fraction divided by another, you just change the division sign to a times sign and flip the second fraction upside down. Well, the first number here isn't a fraction, you might say. Well, now it is. 1 over 1. Same thing as 1. I've turned it into a fraction. Okay, so 1 over 1 times 2 over 13. Excuse me. I actually didn't follow the rule there. Times 13 over 2, I should say. Okay, and 1 times 13 is 13. And 1 times 2 is 2. So the reciprocal of 2 over 13 is 13 over 2. It's just the fraction flipped upside down. Okay. All right, guys. I know that was a little bit long, but I thought since we haven't touched base for a while and I was sick at the end of the term, I really just wanted to go over all of the skills with you that we've covered so far. We've got one more lesson on fractions that has new material where we're looking at indices, powers of fractions, okay? And then we're going to start looking at a new topic. All right, goodbye.